Signals and Systems Assignment. Assignment help. For any help regarding signals and systems assignment help, visit https://www.matlabassignmentexperts.com/www.matlabassignmentexperts.com. Email info@matlabassignmentexperts.com, info@matlabassignmentexperts.com, or call us at +1 6786 484277. Signals and Systems. Problem 1. A. Does the Fourier transform of this signal converge? B. For which of the following values of a does the Fourier transform of xt, converge? C. Determine the Laplace transform XS of xt. Sketch the location of the poles and zeros of XS and the ROC. Problem 2. Determine the Laplace transform, pole and zero locations, and associated ROC for each of the following time functions. Problem 3, shown in figures P20.3-1 to P20.3-4 are 4 pole zero plots. For each statement in table P20.3 about the associated time function xt, fill in the table with the corresponding constraint on the ROC. matlabassignmentexperts.com. matlabassignmentexperts.com. Constraint on ROC for pole zero pattern. Problem 4. Determine xt, for the following conditions if XS is given by A. xt is right-sided, B. xt is left-sided, C. xt is two-sided. matlabassignmentexperts.com. Problem 5. An LTI system has an impulse response h, t, for which the Laplace transform Hs is. Determine the system output y, t, for all t if the input xt is given by. Problem 6. A. From the expression for the Laplace transform of xt, derive the fact that the Laplace transform of xt is the Fourier transform of xt, weighted by an exponential. B. Derive the expression for the inverse Laplace transform using the Fourier transform synthesis equation. Problem 7. Determine the time function xt for each Laplace transform XS. matlabassignmentexperts.com. Problem 8. The Laplace transform XS of a signal xt has 4 poles and an unknown number of zeros. Xt is known to have an impulse at t equals 0. Determine what information, if any, this provides about the number of zeros. Problem 9. Determine the Laplace transform, pole zero location, and associated ROC for each of the following time functions. matlabassignmentexperts.com. Problem 10. A. If xt is an even time function such that xt equals xt, show that this requires that xs equals xs. B. If xt is an odd time function such that xt equals xt, show that xs equals xs. C. Determine which, if any, of the pole zero plots in figures P20.10-1 to P20.10-4 could correspond to an even time function. For those that could, indicate the required ROC. matlabassignmentexperts.com. D. Determine which, if any, of the pole zero plots in part C could correspond to an odd time function. For those that could, indicate the required ROC. matlabassignmentexperts.com. Solution. Solution 1. A. The Fourier transform of the signal does not exist because of the presence of growing exponentials. In other words, xt is not absolutely integrable. B. For the case a equals 1, we have that. Although the growth rate has been slowed, the Fourier transform still does not converge. 2. For the case A equals 2.5, we have that the first term has now been sufficiently weighted that it decays to 0 as t goes to infinity. However, since the second term is still growing exponentially, the Fourier transform does not converge. 3. For the case A equals 3.5, we have that both terms do decay as t goes to infinity, and the Fourier transform converges. We note that for any value of a greater than 3.0, the signal xt, e' decays exponentially, and the Fourier transform converges. C. The Laplace transform of xt is Matlab assignmentexperts.com. And its pole zero plot and ROC are as shown in figure S20.1. Note that if a greater than 3.0, S equals A plus JW is in the region of convergence because, as we showed in part B, 3, the Fourier transform converges. Solution 2. Matlab assignmentexperts.com. As shown in figure S20.2-1. The Laplace transform converges for re tilde S plus A0, so as shown in figure S20.2-2. Matlab assignmentexperts.com. Matlab assignmentexperts.com. Solution 3. Since the Fourier transform of xt, E tilde exists, A equals 1 must be in the ROC. Therefore only one possible ROC exists, shown in figure S20.3-1. 2. We are specifying a left-sided signal. The corresponding ROC is as given in figure S20.3-2. Matlab assignmentexperts.com. Solution 4. 3. We are specifying a right-sided signal. The corresponding ROC is as given in figure S20.3-3. B. Since there are no poles present, the ROC exists everywhere in the S-plane. C. A equals 1 must be in the ROC. Therefore, the only possible ROC is that shown in figure S20.3-4. Matlab assignmentexperts.com. 2. We are specifying a left-sided signal. The corresponding ROC is as shown in figure S20.3-5. Matlab assignmentexperts.com. 3. We are specifying a right-sided signal. The corresponding ROC is as shown in figure S20.3-9. Constraint on ROC for pole zero pattern. Matlab assignmentexperts.com. Solution 5. A. For xt, right-sided, the ROC is to the right of the rightmost pole, as shown in figure S20.4-1. Using partial fractions. B. For xt, left-sided, the ROC is to the left of the leftmost pole, as shown in figure S20.4-2. Matlab assignmentexperts.com. Since we conclude that C. For the two-sided assumption, we know that xt will have the form. We know the inverse Laplace transforms of the following. Matlab assignmentexperts.com. Which of the combinations should we choose for the two-sided case? Suppose we choose. We ask, for what values of a does xt, e-0 fit have a Fourier transform? And we see that there are no values. That is, suppose we choose A-1, so that the first term has a Fourier transform.